Hello everyone, welcome to lecture 16 on numerical analysis. In the last lecture, we have started unit 2, that is finite difference operators. Okay, so we have seen finite difference operators, that is forward difference operator, and second forward difference operators, third and fourth and so on, nth difference operators, leading differences, and we have seen the forward difference table, and we have seen some examples also. Okay, and the last example, I have intentionally done a calculation mistake here. 9 minus 4, that is 5. Okay, so please correct it. So I have done this intentionally, but none of you have replied so far. Okay, anyhow, let us see. This 9 minus 4 is 5. Okay, then the second forward difference, that will be 8 minus 5, that is equal to 3, and this is 5 minus 8 minus 3, so minus 3 minus 3, so this is going to be the third difference. Okay, so that is minus 3 minus 3, which is equal to minus 6, right? So like this we have seen how to construct the forward difference table, forward difference operator, and so on. Okay, so now let us continue further. Right, see, what we have been doing is nothing but we have a function y is equal to f of x. So we have a function y is equal to f of x. See, given a function explicitly, suppose if f of x is given to be x square, then for all x, okay, so for all x we will be having an output, that is x square. Okay, suppose x is 1, then it is 1, 2, then it is 4, 3, then this is 9, and so on. So this is what we do regularly. Given a function y is equal to f of x explicitly, then we get the x values, and we substitute the x values and we get the y value. But in the numerical analysis, in the numerical analysis, we go for the converse part. We go for the converse. So that means this thing is given. This values will be given. Okay, for say the order pair 1 comma 1 represent x1 and x square 1, and this is 2 and 4, 3 and 9, and so on. This is given, and we need to find the function. We need to find the function. So find f of x. So in the numerical analysis, this is a reverse question. That is, the values of x and its corresponding function value will be given, and we need to find a function explicitly. Okay, we need to find the function explicitly. So this is what we are doing in the forward difference table, as we have seen in the previous example. See, x values are given and its y values are given, and we need to find out the function approximately. So that we do, we assume that the phi of x is an approximate function to the function f of x, and we estimate phi of x based on the estimation of the phi of x, and we conclude that the f of x will be something like this, and that's all. Okay, so that is what the basic idea of numerical analysis. So we have the x values and their y values, and we need to find out the function explicitly. So as of now we have seen the forward difference operator, forward difference operator. Okay, so for that we are denoting this delta. So this is called delta, and we are denoting this as a forward difference operator, and it is defined as f of x plus h minus f of x, where h is step length or this is a step length or an increment, right? So when we have delta as f of x plus h minus f of x, and we can calculate the delta square, that is a okay second forward difference operator of f of x. So that is nothing but a delta of f of x. So that is nothing but delta f of x is nothing but f of x plus h minus f of x. So when you apply delta to this value, this becomes the second order or second forward difference. Okay, but one need to be very careful here. So this delta is distributive. So this can be written as delta f of x plus h minus delta f of x. See, delta has been distributed over this addition or subtraction. So this property of delta is called linear property. This property is called linear property. So we need to prove that delta is distributive over addition or subtraction. So we need this linear property. Okay, so we need to say that, or we need to prove that the forward difference operator is linear. Forward difference operator is linear. So before we go for such proofs, and we shall see different another operator, that is second operator, backward difference operator. Okay, so second one, backward difference operator. So as we have seen forward difference operator, similarly the backward difference operator can be defined as this reverse of the forward difference operator. So therefore we are going to define the backward difference operator as the backward difference operator. So it is just a reverse of forward difference is defined as, so is defined as so this operator, it is denoted by reverse of delta, it is called del. So it is a backward difference operator. So we denote the backward difference operator by del. Okay, so it is defined as del of f of x, which is equal to f of x minus f of x minus h. So now please compare the two operators, delta and del. See, delta f of x is nothing but f of x plus h minus f of x, and backward difference operator, that is del f of x, is f of x minus f of x minus h. Okay, so please see the difference in the forward difference. We are taking x plus h and f of x. Okay, if there are in the table, say x1, x2, x3, x4, and corresponding y1, y2, y3, y4. So forward difference is difference between y2 and y1. Okay, difference between y3 and y2, difference between y4 and y3. So this is what forward difference, delta 1. But the backward difference is f of x minus f of x minus h. Okay, So how do this backward difference table? So we take f of the final one and we come in the reverse order. This is in this direction from top to bottom. For backward we go for the bottom to top. Okay, so that we shall see now. So some more information about backward operator can be given. See, backward difference operator, that is del f of x is equal to f of x minus h minus f of x. Okay. Yeah. So this is nothing but, so if you take it as a y1, okay, that is f of x1, then this is y1 minus y2, and del y2 is nothing but y2 minus y1, and so on, etc. Okay. So therefore, the order second backward difference, that is del square f of x, which is equal to del of f of x minus f of x minus h. So that is nothing but del of f of x minus del f of x minus h. So del f of x is nothing but f of x minus f of x minus h minus f of x minus h minus f of x minus 2h, right? So because already this is f of x minus h here, so del f of x minus h is nothing but f of x minus h minus f of x minus 2h. So this is equal to f of x minus 2 times f of x minus h minus f of x minus 2h. Okay. So that is a second backward difference operator. So on, nth difference operator can be obtained. Okay. So that is third difference operator, and so on. The nth, sorry, this is not a del, this is a, we need to place a del there. Yeah. So be careful about delta and del. So this is delta, capital delta of English Greek letter. This is called del. Actually, this is the actual name is nabla. In the Greek letter, this is nabla, but we are taking just del as an backward difference operator. So delta is for forward difference operator, and del is for backward difference operator. Okay, and so on, del cube, so on, del raised to n, that is nth backward difference operator, as same as we have done in the forward difference operator. Okay, here see here we have seen the nth order forward difference operator, and so on. Same way we are going to have a backward difference, nth order backward difference operator. Okay. Yeah. So now let us see the backward difference table, how it looks like. Backward difference table. Backward difference table. See, as usual, we have the x values and y values, and this is first backward difference, del y, del square y, del cube y, del raised to 4y, and so on. Okay. So x value should be, we know, x1, x2, x3, so on. So this is x1, or say x0, x1, x2, x3, x4, x5. So this is y0 corresponding to x0. This is y1 corresponding to x1, y2 corresponding to x2, y3, y4, and y5. Okay. So now to do the backward difference table, we need to start from y5. Okay. So y5 minus y4. Okay. So this is first backward difference, that is denoted by y5. So this is del y4. This is del y3. This is del y2. So if you take this difference, this is del y. If you take the difference between, again start from here, so the table is going upward from the downward, so you must be very careful. Okay, the table is going upward. So in order to get the second backward difference, we see these two. So that is del y5 minus del y4. So this is nothing but del square y5. Okay, and this is del square y4. This is del square y3, and this is del square y2. So this is going to be a diagonal table. So from here to here, this will go in a diagonal way. So this difference is equal to del cube y5, and this is del cube y4, and this is del cube y3. You can observe here, del y was there. There is no del square y. So it has reduced to one step, that is del square y2. Del square y2 was there. When it comes to the third backward difference, there is no del y2 term, so it is reduced to y. So when it goes to further, so this is del raised to 4 y5, and this is del raised to 4 y5, and this is del raised to 4 y4. So if you take one more, that is del raised to 5y, then this is going to be del raised to 5 y5. So that means what? The final term, or the last term which we get in the y, that term is leading diagonally. Okay, so we are going to get an answer from backward like this. Okay, so if you write it in a clear manner, so shall I think you can get it in a clear manner. We shall see how the backward difference table works with an example. Okay, yeah. So next we shall discuss about one more operator. This is a backward difference table. Okay, you can neatly arrange this, and you must be in the backward difference table. The table moves from bottom to top, and in the forward difference table, top to bottom. Okay, 9 minus 4 is 5, 17 minus okay, well, we can make this one as a backward difference now. So now let us see the same table can be converted into backward difference. So let us see how we can do. So already we have x and y values, right? So it was 17, right? So the same table we are going to see how it works in the backward. So when it works in the backward, it is moving from bottom to top. Okay, yeah. So now, so this is del f of x, del square f of x, del cube f of x. What is del f of x? 22 minus 17. The table has to move from bottom to top, so that is going to be 5. Okay, and this one 17 minus 9. What is 17 minus 9? It is going to be 8, right? And 9 minus 4 is 5. So again, so to find delta square, del square f of x, so that is 5 minus each, and this is 8 minus 5. 5 minus 8 is minus 10. This is to find del cube. So this is minus 3 minus, this is going to be minus 6. The table remains same. Okay, the table remains same for the forward as well as backward table in this case, but you can observe that this is diagonal, this is going to be diagonal from the bottom. This is going to be diagonal from the bottom, whereas in the forward difference table you have observed that this is going to be, this is going from the top, here it is going from the bottom. Okay, diagonal, it is going to be diagonal from the bottom, and here it is diagonal from the top. Okay, so why this backward and forward differences has to be taken? So now there arises a question, why these forward and backward differences to be considered? So why forward and backward differences to be taken? So to answer this question, as I said beginning of this lecture, see, the main purpose of the numerical analysis is to is to find the function f of x explicitly. Okay, so these x values and y values will be given, and we need to find this f of x. That's what we are going to do in the numerical analysis. So now let us compare the table. Okay, see here the x values and given, its corresponding f of x value is given, and we don't know what is y is equal to f of x explicitly. That is what we need to find out. Suppose if you want to calculate value of the function at any intermediate values between minus 2 to 4. See, this is a range which is given, x lies between what? Minus 2 to 4. If you want to find out any value of y for any x lying between minus 2 to 4, suppose if you want to find out x is equal to 1, I don't know what is the function, and I want to find the value of function at x is equal to 1 using this table, then how do we are going to do? So x is equal to 1 lies somewhere here, right? Yeah, first take x is equal to minus 1. X is equal to minus 1 lies somewhere here. It is nearer to the first term, therefore we go for the forward difference table. Okay, if the value of x which is given to find the value of f of x is nearer to the first term, then we go for the forward difference table. Suppose if you are asked to find out what is the value of f of x at x is equal to 3, then x is equal to 3 lies somewhere here at near to the last term, then we go for the backward difference operator. Then we go for the backward difference operator. That is what the importance of the forward difference and backward difference operator. Okay, so I hope we have answered this question, right? So next we shall see another operator, so that is called shift operator. So this is third operator, it is called shift operator. It is called shift operator. Operator is denoted by the letter E. Okay, it is denoted by the letter E, and it is defined as. So this is sometimes we'll call this shift operator as displacement operator. Or translation operator. There are three different names for this operator. Generally, we call it as shift operator, that is denoted by E. So we define the shifting operator, the shift operator E as. So when you apply this operator to a function f of x, the output which comes is f of x plus h. Okay, so do you understand? So if I am applying this operator to the function f of x is nothing but y, so with x, then the output will be y of x plus h. Okay, so for example, see, if I am going to apply this for shift operator for y1, this is going to be y2. Okay, so if you are going to apply to y2, then the output will be y3 and so on, right? So that means it is shifting one place. The x is shifted to x plus h. This shifting x is shifted to x plus h. So y1 is shifted to y2, y2 is shifted to y3 and so on. Okay, so that is what the shift operator does. It pushes one term forward. It pushes the function, pushes the term, instead of function you can say it pushes the term one step forward, one step forward. So if you are applying the shift operator to y1, then it is going to be y2, the output is y2. If you are applying to y2, then the output is y3 and so on. Suppose if you are applying this shift operator, already I have applied shift operator to y1. Again if you want to apply a shift operator, so that is going to be e of y2, which is going to be y3. So that means two steps. So this is e square f of x, e square yx. Okay, so if you apply twice, then it is moves two steps. See, here it is 1 and it is moved to 3. Okay, so if you are going to apply for the n operator, so n times, if you are going to apply n times to the x, so this can be written as y plus x plus 2h. Okay, if you are applying this n times to yx, then the output will be yx plus n times the h. Okay, or if you take it as a f of x instead of yx, this is easier to understand. So then the output will be, what is the output? So output will be f of x, right? You are operating the shift operator. If you apply one time, then it is x plus h. If you operate two times, then it is x plus 2h. If you apply three times, then it is x plus 3h and so on. So this is going to be f of x plus nh. This is going to be f of x plus nh. Okay, so we shall see explicitly. So we shall put n is equal to 1. So when you put n is equal to 1, this is f of x plus h. For n is equal to 1, so then it is going to be f of x plus h. So for n is equal to 2, this is e square f of x. This is going to be f of x plus 2h. N is equal to 3, this is going to be e cube f of x. That is equal to f of x plus 3h and so on. So when it is n, f of e power n, f of x is equal to f of x plus n h. Okay, so I have this is understand. This is shift operator, means it shifts one term next. That is, if you are going to apply for the y1, it gives y2. If you are going to apply for the y2, it gives y3 and so on, right? So this operator is known as shift operator. So far we have studied three operators till now. So till now we have studied three operators. So what are the three operators? The first operator that we have uh, seen is forward difference operator. So that is denoted by del. The second one is backward difference operator. So that is denoted by delta. The first one is delta, and this is del. The third operator which you have studied is shift operator, and it is denoted by what? E. It is denoted by E, the capital English letter E, right? So we shall see in the next class what is the relation between the these three operators. So relation between delta, del and E. Okay, so we shall see what is the relation in the next class. Thank you.